Hello guys, hope you all doing good. So today we have come up with a new project title which is a brain tumor detector, which is completely under the deep learning concepts. So specifically if I want to mention, it is a type of deep learning which is a CNN, which can able to handle the data like images, videos and all. So, as a note, as previously we have taken and solved couple of projects. If not, do visit that as well. And specifically on machine learnings, we have covered both supervised and unsupervised learnings there. And here we are doing a project which on the deep learning concept in the CNN. So, by seeing the project title itself, Brain Tumor Predictor, we haven't some idea about it, right? So, what we are going to predict. So for that, I would like to show a quick interface how I have created within my stipulated time. So I just browse my files here. So here is the um, just a minute. Yeah, here is the tumor data set. Within I have three for training data, for validation, and for testing. So here I am going with the testing. So the goal of the project is it to uploading a MRI scan, we are going to predict either the brain image as a tumor or not. Okay. From that, we have a four classes here. One is a no tumor, and other are the tumor types. So the first tumor type is meningioma and glioma, and the last one is pituitary. If the brain scan image has a tumor, it will predict any one of the among the three. If it is not a tumor, it will predict as no tumor. So as firstly, we'll go with the new no tumor type. So I'm just choosing this as looks bright. Just opening my file, it gets download. Yeah, it is the image and it will predict as no tumor with a confidence of 58. So it says this image is belongs to no tumor with a confidence I can say 58%. And we can also see the other class probabilities here. Glioma, there is no possibilities of having glioma with this image. And meningioma, which has 39.57 of possibilities, and followed by the pituitary. So now you can decide how much this application would be useful. And before that, when you're working with any of the project, we have to know what is the problem we are facing and why we have been doing this project, what we are going to accomplish with that. So always we have to a clear idea about that. So here the problem we have faced is, so if a person has a brain scan, we need a neurologist, right? So neurologist have a look on this particular image, and that neurologist will decide so what type of tumor it is and if it is a no tumor and all. In this situation, we all knew that there is a human error. To avoid that, we may use this application as a first step, right? So now we may know how this is contributing in all of the fields. Okay, after that we'll get into the coding part, what it does behind the process actually. So this is the whole steps include. So I always used to say starts with importing the necessary libraries, then mounting the drive and the data pre-processing. Here I'm using an augmentations. After that, building the custom model, which is nothing but a customized model. Afterwards, I'm using the transfer learnings. Transfer learnings is nothing but using a pre-trained models. Pre-trained models means it is already trained with a lot of data sets. And then I'm saving my best model for my future references. So here is the importing necessary libraries. I'm using here the TensorFlow framework from a deep learning. So if you are well with PyTorch, please go with that as well. And here mounting my drive. So here for this coding part, I am using a Google Colab. The reason behind it for using the GPU support. Here you can click this icon and click this change runtime. It is always the standard. It will be in CPU. Please change to GPU and you can click the save. Okay. After that, it will rerun. For using GPU support means it can capable of handling enormous amount of data, we can say, and it is very much well when handling the image and videos related data. So you may have a research on that as well. So here is my drive. So it is just connecting. Let me show you later. So as now I couldn't connect because yesterday I have used more of my GPU. Yeah, here it is. And here is the classes for each data set. After that, this is my image count of each of my data set. Here's the data pre-processing and augmentation step starts with. For that, I'm just first step rescaling. Here I mentioned as 225 with dividing with each pixel. 225 is nothing but it is an RGB count. RGB is basically from 0 to 225 is totally 256, right? So I'm doing that. It is the augmentation parameters that I have used here. Because augmentation is nothing but creating multiple images artificially in different ways, right? So here is a single image. It will be very clear if I'm showing the image. So here is the single image, original image. So these are all the artificially created images. So as the first thing you may see, it is somewhat increase the brightness. A second, you may see it is flipped, and third, it is rightly aligned. At last, it is something down. So with a single image, we can able to create a multiple images in different ways, because in real time we couldn't have the image like this. We couldn't have a standard image. Sometimes it can be zoomed in, sometimes it can be zoomed out, brightness added, it's sometimes dull. So as aligned with the real-time data, we'll be creating the all of the possible multiple images. So as it is also useful for generating a lot of training images, right? Yes. Here I am applying my data augmentation process with my original images. So for that I am specifying the image width and height. I am specifying my batch size as 40. So as image size could be anything. So I am reshaping into a 224. And here I am applying into train generator with my augmentations. Guys, augmentation is only for a training, not for validation, not for test. The test and validation must be unseen to the model, right? Yes. Then here is the total classes. Here, how many classes we have? A glioma, meningioma, pituitary. So these are all the tumor types, and no tumor is a no tumor. And the number of classes is 4, the count of the class. And here the actual step starts with the customizing a model building. For that, I'm using here the sequential API. In that, I am using a convolutional 2D layer with a max pooling. Here, I'm using 3 into 3 matrix with the 32 filters with the activation function of ReLU. Okay, what is an activation function, or is the main purpose of using activation function in deep learning concepts? Okay, just do a process on that. It is a max pooling, and I'm using this as 3 steps with increasing the filters, right? And I'm using a flattening here. Flatten is nothing but whatever the dimension it is, flatten used to convert into the one dimensional, okay, one dimensional vector. For okay, then we'll be making a many dense layers. In between, we'll be using dropouts to avoid the overfit. At last, we'll be using the dense layer for the output layer. Here is the output would be number of classes. Here, number of classes is 4. So coming back, activation function is nothing but just in a mathematical function is mainly used to make non-linear relationships with the data. I'm here compiling my data using an optimizer as Adam and using loss function as categorical cross entropy. So okay, here we'll be solving the problem of multi-classification. So if our output is binary, what is the loss function? What is the loss function? It's none other than it is a binary cross entropy. Binary cross entropy. Okay. If it is in a problem is in binary, we'll be using binary cross entropy. It's PY. Okay. Okay. Here the metrics I have used to evaluate is accuracy, recall, and precision. Okay. If you're okay with, you may use the FN score as well here. And here is the model summary. Guys, here is the actual step, training my custom models. I am here training with epochs of 10. Epochs is nothing but how many times my model sees my whole training data. How many times my model sees the whole training data. Okay, here 10 times my model is going to have a look on my whole training data with a batch of 40-40. Okay, here 43 is present. Just do just a mathematical calculations. So here what I did, yeah, here I mentioned batch size as 40. So at each time, it will process 40 images. So I don't want to leave this. I will let you know clear. So here is the training images. Okay, count all of these 564, 358, 335, and 438. So here is the count of the training images. So I will count it quickly. It's 161695. Okay, it is the total training images. With that, I am dividing by batches. Each batch 40 images has been processed. So divide by 40. Okay. How many I get? 42.3. So as totally I get 43 times each epoch will run, right? 43 times each epoch will run, same as it will run as 10 epochs. So by using a custom model, I get the accuracy of here 67 percentage. It is quite performing well. For that, I am saving my custom model here. After that, let me discuss in a with a confusion matrix. So it's very much important. Just show your interest here. So here we have a predictor, and as here we have an actual data. So have a look here. 66 of glaucoma is rightly predicted as glaucoma, and 4 of glaucoma is predicted as meningioma, and 7 glioma is predicted as no tumor. Guys, do think if 7 glioma disease has been predicted as no tumor, what if a person comes and upload it and gets as a no tumor, even if the person has a glioma? Okay, it's very risk, right? So as we'll be handling the medical related images, it is very specific things. It is sentimental. Okay, and here 3 glioma is also predicted as pituitary. And here we see 11 meningiomas predicted as glioma again. Only 19 meningiomas rightly predicted as meningioma. So here we may see so much is wrongly classified because here we get the accuracy of only 67% using a custom model. So that's why we'll be much focusing on increasing the training data, avoiding the overfittings, and also we'll be focusing with the accuracies with the test. And then is the transfer learning. Transfer learning, I said already, it is the pre-trained models will be incorporating here. For here, I'm using 5 transfer models I could randomly picked and used here. So it can be trained with lakhs and millions of data with a classes of thousand and two thousands, right? So first, I'm using a VGG transfer learning. By using VGG 16, I get the accuracy of 76, which is quite well with compared to my custom model. And second, I'm using ResNet 50. By using, I get it around 73%. And third one is the quite popular MobileNet V2. So let's see how much percentage we get. We get around 84. Okay, it's quite performing well. So this is the one which you're going to use in our project. And fourth is Inception View, and fifth is Efficient BO. So at last we'll see the as the comparison. So this is a model comparison. So have a look which model is performing well. So MobileNet is performing well on all of the accuracies. Okay, so we'll be saving the MobileNet and we'll be using in our application. So here is the performances as well through our visualization. So this is what behind the application. Okay. So also let me show you with different images. As again with the no tumor, I would like to check another image. So I'll go with this. Something looks dark. So here, yeah, it is again predicted right with the no tumor with the confidence of 62%. So I will browse and I'll go with any tumor type. So we'll go with meningioma. I'm choosing here a second one. Let's see. Yeah, it is rightly classified as meningioma with a probability of 76%. Okay. And also we can see through the visualizations and be ever have a look on this node when we are developing a medical related applications. So let's browse file again. Let's see any another type of tumor. I go with glioma. So I choose. Okay, I'll go last better. Okay, I'll go with this. So what it is predicting? Oh, again, it is rightly predicted as glioma with a confidence of 88.10. So one is pending. We also check the pituitary, how it checks. So I'll go with something looks different there. So I'll click this. Let's see. Yeah, it is also rightly classified as pituitary with the confidence of 67.67%. So this is how my user interface will looks like. And here is the dataset summary, which we have already seen with the four classes. And here is the model performance comparison we may see. We may see to a visualization here I have plotted. From seeing, we may get to know its mobile net is quite performing well with all of the accuracies. So I'm choosing best performing model. So okay, it is the mobile net with a performance of 85%. At last, is a data set summary visualization so we can see how much it can be contributing to the data set. So this is how my application will look like with the coding part. Thanks for watching. Stay tuned. Thank you.